Actually, the last talk given by the Cossas from National Tsinghua University. This is a contributed talk on site. He is going to talk about possible ALMA counterpart of FRB 12. Yes. So Cossas, please start.
Okay, hello everyone. My name is Cossas, a master's student from NTHU. And today I want to talk about the possible ALMA counterpart for FRB 121102, which is briefly mentioned in the morning and the afternoon. So while we were trying to detecting the counterpart for FRB, so in current models that from magnetosphere models or a Mason model from the previous work, they predict very different multi-wavelength counterparts like optical, X-ray, or even the sub-millimeters. So in this sense, magnetosphere model will likely to prefer observe sub-millimeter counterparts and instead of Mason model. And here shows the prediction of the, even though it is a same frequency, the models has a pretty different time scale in both X-ray and opticals. So also next the SED. Okay, the SED of the host origin is helped to differentiate the mechanism of the FRBs. So this word, ALMA, the green arrows and blue arrows are placed to the 3 sigma limit for the 1 second time resolution and 1 minute time resolution, and respectively. And you can see that now the observation done in optical and XMN and also by VLA prefer the environment of FRB tends to be located at trapped nebula-like systems instead of the radio loud AGS. So now let's talk about our object, our target, FRB 121102. So it is a repeating FRB, sits inside the star-forming region in its host galaxy, and importantly, it has a very high burst rate. It can produce 21 bursts in 1 hour, and it has a periodicity of around 160 days. So this consists of 90 days active and the 70 days off. And in this ALMA observation, this is it is within the active phase of the FRB 121102, and also there's a precision source detected with VLA shows in the right hand side figures, which is around a second around the position of the FRBs. So let's talk about our data. So in a day 1, we see no clear detection in the first day. So each day, ALMA spends 1 hour on this source to observe the possible counterpart or the FRB host itself. And this continuum is from 90.5 gigahertz to 104.5 gigahertz, and it has 4 spectral windows, each consist of 1 gigahertz bandwidth. And we can see that there's a marginally detection on the second day, with a marker shown in red. So, however, we don't know because typically FRB has a shorter spectral width that is much smaller than the continuum band. Then we split this in the data into the 4 spectral windows and see if there's a meaningful extraction from the source. And sadly, we see no detection from both first tape and the second tape. Okay, so then now we try to, because the different models predict very different time scale of FRBs. So it might be appears in 1 second or milliseconds or just few tenths second or 1 hour. In sub-millimeter, we don't know. But so we try to first analyze the time resolution with 55 seconds, around 1 minute, and we found 2 promising peaks shows in panel A and panel B. The yellow circles serve as the brightest peak inside the host galaxy of this FRB, and both detection is within 2 sigma of the ALMA position uncertainty on the FRB's position. And we see the non-detection as the C panel. So here's my summary. So multi-wavelength observation for FRB are very important to tell the difference between the models and models. And our model didn't provide a very clear signal of the counterpart or the detection of B, A and B is a counterpart or the galaxy or the precision source seen by VLA. So that means this time resolution, 55 seconds, might not be the ideal observation span that can directly observe the FRBs. So maybe higher time resolution for ALMA or simultaneous observation with other telescopes such as VLA, GPT are needed for direct identification of this kind of FRB counterpart detection. And that's all. Thank you.
Okay, thank you very much. So, is there any questions from the on-site audience? Oliver, please.
Hello. So do you have any concrete plan on improving the visibility of this project?
So, okay. So in this, the ALMA data set, the minimum time resolution is 1 second. So I think now the ALMA has upgraded its correlator, so it can be the time resolution can be finer into the milliseconds time scale. That might be helpful to identify the counterpart of the FRB in sub-millimeter wavelength.
Thank you. Thank you.
Okay, Susumu, please go ahead.
Okay, you already answered my question. I was going to ask how down to what time scales you can go with ALMA, but okay, 1 second maybe. Yeah.
Okay, thank you.
Yeah, thank you.
Okay, thank you very much. If I could add a little bit more, as far as I understand, ALMA recently started the new pulsar mode observations. And then if you can use that mode, I think you can go further into the shorter resolution, I think, say millisecond or even shorter, if I correctly understand. But I think this is a really new function, so therefore we have to try to use it.
In future.
Yes, in future, yes. Any other questions or comments? Also, I wanted to add a little bit more to answer to Oliver's question. As Cossas mentioned, actually, the simultaneous observations between FRBs and then this ALMA will be really important, because in this work, we didn't have the simultaneous observations, you guys remember. So therefore, in order to really constrain the sub-millimeter counterpart, so we need a FRB detection simultaneous. So therefore, maybe to go further, maybe we need coordinated observations. Okay, so thank you very much. If no more questions, let's thank the speaker again.